Hi, future doctors. Welcome to the next class. So we will see combination of cells, combination of cells. Already we have seen capacitors connected in series, resistors connected in series. Now series combination means end-to-end connection. A cell which is having internal resistance R1, EMF E1, and another cell which is having internal resistance R2, EMF E2. So both got connected here, end-to-end connection. Now what is the effective EMF between A and B? Okay, so EAB is equal to. So if you combine these two, you will get another cell. It is called E equivalent, and internal resistance R equivalent. That is going to be AB. Correct? Now, how we are going to get this one means whenever two cells connected in series, so they will do VAC first, VCB, then they will calculate VAB. So if you do like this, you are going to get simply E1 plus E2. So this one you can remember directly, easily, therefore without derivation we have seen. But in parallel combination we will see how the derivation also coming, because in some board exams they will ask that one. Now, what is equivalent internal resistance? R1 plus R. What is same? If cells in series means no current is going to be same. Correct? Right. So this is about equivalent EMF, equivalent internal resistance when cells connected in series. Series combination means here negative end is connected here for positive end. Suppose if you connect like this, negative end is connected with negative R1, E1, E2, R2. Now, what is the effective EMF or equivalent EMF? EAB is equal to, whenever you got negative with negative or positive with positive, you will write E1 minus E2. R equivalent, same one, R1 plus R2, because these two in series. This one is very, very important. Next, if n identical cells, if n identical cells connected in series, see here. So E comma smaller, E comma smaller, smaller means internal resistance. This is connected between A and B. Now what is the effective EMF? So EAB, equivalent EMF, is going to be E plus and so on E. What you will get? NE. Now what is R equivalent? R plus and so on R. How many R's are there? NR. Now all these connected correctly. Negative is connected with positive, negative is connected with positive. So they will give, if two cells or one cell is connected wrongly, let us assume, we will see for four cells. So E, so internal resistance, small r we will assume. Now within this, see, negative is connected with positive. This is correctly connected. But here one cell is connected, negative is negative. Correct? So negative is negative. Negative is negative means, so here we will write effective EMF E minus E. So if you remove these two, see, this is negative is connected with positive. Therefore these two will be correct. Otherwise, you can write formula E equivalent is equal to E This is connected correctly, plus E. This is wrongly, minus E, plus E. Therefore, you got 2E. So, if you connect one cell wrong, so it is taking along with the another cell, means two cells will be gone. Like that, if you connect two cells wrong, then four cells will be gone. Like that, if you got X cells wrongly connected in series combination, X cells wrongly connected within this N identical cells, then how many cells will be gone? For one cell, two cells gone. For two cells connected wrongly, four cells gone. For X cells connected wrongly, how many cells will be gone means 2X. Then what are remaining cells? What are remaining cells means how many cells are there here? N cells. Therefore, how many remaining means N minus 2X. Then what is the equivalent EMF? Means N minus 2X into E. What is the equivalent internal resistance? If you connect like this or like this, internal resistance will not change. That is NR. So how they will give problem on this we will see. If 12 cells, 12 identical cells, each of EMF 2 volts, internal resistance 1 ohm, connected in series. A student is asked to connect 12 cells in series, each EMF 2 volts, internal resistance 1 ohm. But he connected 2 cells wrongly. 2 cells wrongly. Then what is the effective EMF? Effective EMF means, now see this formula. So N minus 2X into E, because X cells connected wrongly. So total number of cells, 12. So 12 minus 2 into 2 cells connected wrongly. Each voltage 2 volts. So 12 minus 4, 8 into 2, 16 volts. Understood? Now what is the equivalent internal resistance? That is 12 ohms. 1 plus 1 plus 1. So 12 resistors, therefore 12 ohms. Now, all these n identical cells connected correctly to an external resistance capital R. Then what is the current passing through that capital R they are going to ask. How many cells we are connecting? N cells. Each EMF, small e, internal resistance, small r, E comma R. Now, this is connected to an external resistance, capital R. Then how much current will be passing through this? Now, this one will convert into a simple cell. If you combine all these, you will get E equivalent, R equivalent, and this is connected to external resistance, capital R. So, already we gave this equation for you. So, I is equal to, what is the current now? I is equal to E equivalent by capital R plus R equivalent. Understood? This one already we gave. So, now this is simple circuit. Now, what is E equivalent? E equivalent is N. What is R equivalent? NR. Substitute this. Now, I is equal to NE by R plus NR. This is the current passing through this external resistance. Now, I told you condition for maximum current. Condition for maximum current. What is the condition for maximum current means? So, if current wanted to be maximum, NE by, what is the condition I told you? Denominator whichever there you have to equate. Therefore, capital R equal to NR. This is the condition for max. Capital R equal to NR means substitute here. So, NR plus NR or NE by capital R plus capital R. So, NE by 2 NR or NE by 2 capital R. So, if you cancel small n and small n, that is going to be E by 2 small r or NE by 2 capital R. So, this is the condition for maximum current. So, sometimes they will ask this question. So, how many number of cells should be given? How many number of cells should be given to get maximum current they will ask. At the time, capital R by small r you have to write. Let us assume each internal resistance is 1 ohm, external resistance is 10 ohm. Then how many cells required to get maximum current means 10 by 1. Let us assume each internal resistance 2 ohm, external resistance 10 ohm. Then how many number of cells should be in series to get maximum current means 10 by 2. That is nothing but 5 cells required. So like this they are going to ask. So try to practice. So wrongly connected cells and equal n identical cells in series to an external resistance capital. Thank you.